Hi everyone. Now I am going to discuss about the motion in a straight line first lecture. In that first lecture, I am going to discuss about the relations between the kinematic terms like distance, displacement, speed, velocity, average velocity, average acceleration, and uniform motion and non-uniform motion. In a straight line motion, I am discussing now. First straight line, I am going to the what is the meaning of distance and displacement. You know, the meaning of distance is nothing but length of the actual path covered by the body in a given interval of time. Length of the actual path covered by the body in given interval of time. Next, displacement. Displacement. Displacement is nothing but the shortest distance between the 2 points. Distance between 2 points. Next, what is average speed? Average speed is nothing but you can say that total distance covered by total time taken. Covered by, I am writing is equal to total time taken. Total time taken. Okay. Next, instantaneous speed. Instantaneous speed is nothing but speed at particular instant. Particular instant. Next, average velocity. Average velocity. It can be written as total displacement divided by total time. Total time taken. Total displacement I am taking like a final position minus initial position. It is a vector. We can write final position vector by minus initial position vector by delta t. You can write. Okay, this is average velocity. Next, instantaneous velocity. Instantaneous velocity is rate of change of position. Rate of change in position. We can write v is equal to dx divided by the dt. As I am taking motion in straight line, I am taking body moving along x-axis. Okay, so v is equal to dx by dt. Average value, average velocity is equal to change in position divided by the delta t. This is a vector. Okay, now average acceleration. Average acceleration. A average bar can be written as change in velocity vector by time interval. We can write it as final velocity vector minus initial velocity vector divided by the delta t. Next, instantaneous acceleration. Instantaneous acceleration. You can write a is equal to a bar is equal to dv bar divided by the dt. This is the instantaneous acceleration. Okay, and one more thing. What is the meaning of retardation? Retardation is nothing but decreasing speed. we can say body is a retardation. Acceleration, body is with increasing speed, increasing speed with time. Deceleration, decreasing speed with time. Or negative acceleration, negative acceleration. Okay. Now zero acceleration. Zero acceleration means body moving with constant velocity. Constant velocity. In a straight line. Constant velocity in a straight line. These are the few terms in this kinematics. Now we are going to see how to calculate this. Let us consider that there is a particle is moving in a circular path. Let us consider this particle is starting from this point A and reaching to the point B. If it is moving and reaching to the point P, if radius is r, point B it is reaching, what is the distance, displacement, average velocity I am writing? Distance covered is equal to, covered can be written as 1/4 of the, you can see here 1/4 of the circle length, we can write as pi r divided by the 2. Displacement, displacement can be written as, it is the shortest distance between the initial and final position. We can see that it is forming a right angle triangle. So r and r we can write it as root 2r is the displacement. What is average speed? Let us consider it is reaching from here, it is t is equal to 0. It is reaching at a time t. Now you can write average speed is total distance is pi r divided by the 2 whole divided by the time taken t. That is average speed. If you want to calculate average velocity can be written as total displacement is root 2 r divided by the t. This is the average velocity. Now we are going to see in other things. Suppose say if any particle is moving in a circular path, let us consider this is covering through an angle theta. Then what is the average speed we can calculate, average velocity you can calculate, as well as distance displacement also you can calculate. First I am writing what is the distance covered. Distance covered is, distance covered can be written as radius is equal to r, we can write as r into theta. Whatever the angle theta is there, we can write it as r into theta is nothing but we can write the 360 degrees is equal to, we can write the 2 pi radians. So we can write it as any angle like a 180 degrees is equal to pi radian. It is a radian, it is also radian. As per the question, we can write the theta value, whatever the theta is there. If it is 120 degrees, you can write it as, if theta is equal to 120 degrees, we can write the 2 pi by 3 you can write. If it is 2 pi by 3, distance value is equal to much? Distance can be written as, I am writing distance value r into 2 pi by 3 you can write. So that's what actually I am going to tell you now. Okay. So that's why I'm not writing anything, just you leave it as a distance only. Okay. Now we can see what is a displacement. Displacement of body can be written as, it is the shortest distance. Like let us consider it is starting from the t is equal to 0 ending at t. Let us consider point A and this is what here point B, turning an angle theta. The shortest distance means, what is the shortest distance? If you make a triangle like this is r, it is making angle theta by 2. This distance can be written as r opposite side r sin theta by 2. This also will get the r into sin theta by 2. So overall we can write the displacement can be written as r sin theta by 2, r sin theta by 2. We can get 2r into sin theta by 2. This 2r sin theta by 2 is angle. Suppose it is 60 degree, 120 degrees is there, we can write the theta by 2 is 60 degrees. Okay, you can observe this clearly. Displacement. If you want to calculate average speed, average speed can be written as V average is equal to total distance is r theta divided by the time taken t. If you want to calculate average velocity, you can write the average velocity can be written as V average value velocity is equal to total displacement is 2r into sin theta by 2 whole divided by the time taken is t. Why I am telling all these things now, in 2023 and 24 they have concentrated from the distance and displacement in a circular path. These terms they have concentrated. That's why I am telling these points. Okay, next one, you can see that if it is moving in a circular path like this only, but it is moving with a constant speed. Let us consider it is moving in a constant speed v, turning an angle theta. Radius is r is given, it is moving like this. So let us consider starting from A and reaching B. So V is constant, speed is constant here. Speed is constant. Okay, speed V is constant. In that case, if you want to calculate the average velocity can be written as total displacement by total time taken. Total displacement divided by the total time taken. What is the total displacement? Displacement, you know that whenever it is moving here, as earlier I said, we can use that total displacement is 2r into sin theta by 2. And what is the total time taken? Time taken t can be written as speed into distance divided by the speed. So we can write distance divided by the time taken. What is the distance divided by speed? Distance divided by the speed. What is the distance covered? You can write r into theta. Whatever angle is there, you can convert into radians, like a 60 degrees or 120 degrees, 150 degrees, whatever angle is there, you can convert that. Speed can be written as v. So we can use that relation r into theta divided by the v. That is the average speed value we can write. As per the question, we can follow that. Okay, if you want to write the further value, we can see r and r get cancelled. Finally, I will get 2v into sin theta by 2 whole divided by the theta. Don't cancel these theta and theta. Theta is there like a in terms of the sine. So you can write it as sine. Suppose theta is 120 degrees. I will write one example. If theta is equal to 120 degrees, then v average value is equal to 2v into sin theta by 2. What is the meaning of sin theta by 2? Sin 60 degrees divided by the 2 pi by 3 you will write. Okay, this is what actually you have to observe this. Observe this carefully, how to write the angles as well as V average speed. Next one, sometimes they will ask you to calculate the some relations, like if they have given like any relation, like x is a function of time taken. So suppose t square plus 2t plus 1 is given. If you want to calculate the average speed, not average speed, average velocity between time intervals like t is equal to 0 to t is equal to 1 seconds they ask. What we have to do? Average velocity. So V average can be written as final position minus initial position divided by the delta t outright. What is the final position? 1 square plus 2 into 1 plus 1 minus initial value is 0 plus 2 into 0 plus 1 whole divided by the delta t value is 1 minus 0. This we have to write. If they ask that find the instantaneous velocity, like velocity at any time. So you can write V instantaneous value can be written as, here in this case we have to write that dx by dt. What is the dx by dt? 2t plus 2 we have to write. If you want to calculate at t is equal to 1 second, what is the velocity? 2 into 1 plus 2 you will write, that value is equal to 4 meter per second. Instantaneous velocity means you have to differentiate. Average value means you have to write the difference. This is what actually I am going to tell now. Similarly, average acceleration also same process we have to follow. Okay, for instantaneous we have to differentiate, remaining things as it is we have to write. Observe this carefully. Now I am going to give the equations of motion. Equations of motion. In any problem, if they give that relation, if body is moving with, if a body is moving with uniform velocity, the relation between the distance or displacement velocity and time taken can be written as displacement x is equal to velocity into time taken. So you can write x is equal to v into t. This is the relation. Now if you want to calculate acceleration value, you will get a is equal to 0 in this case. Only equation is available, that only. Next, if a body is moving with uniform acceleration, if it is moving with uniform acceleration, velocity time equation, you can see that v is equal to u plus at. You know usual meanings. U is initial velocity, v is the final velocity. Next, position time equation. If you want to calculate the position displacement at any time t, you can use the x is equal to ut plus half into at square, and we can write velocity position equation. You can write the velocity position equation as v square minus u square is equal to 2ax. Now distance covered by the body in nth second can be written as x nth is equal to, you can write the value as u plus a by 2 into 2n minus 1. These are the equations of motion when a body is moving with uniform acceleration. Next one, if a body is moving with non-uniform motion, you can use the different relations as per the given question. I am writing now one by one. If position time equation is given, like x is a function of time taken t. To find velocity time equation, use differentiation. So I can write v is equal to dx divided by the dt. This is a velocity. Okay. Next one, If velocity time equation is given, velocity time equation is given like this: v is a function of time taken, or if you are having velocity time equation, to find acceleration time equation, use differentiation. We can write the instantaneous acceleration is dv divided by the dt. This is the relation. Now if you want to find position time equation, then use integration. Now you can write integral dx is equal to integral v into dt. Apply proper limits to calculate the position. Okay. Next one, if position, suppose in the same above problem, if you want to calculate the see, actually I have given velocity time equation. Now if you want to calculate average velocity, to find average velocity, use v average is equal to integral v dt, nothing but that is displacement only, divided by the integral dt. Okay, displacement by total time taken. This is the average velocity. Next one, if acceleration time equation is given, like a is a function of time taken, then to find velocity time equation, use integration. I am writing integral dv is equal to integral a dt. This is a velocity time relation. Next, to find average acceleration, use general integration. You can use average acceleration is nothing but you can see that change in velocity by change in time taken. We can write integral a dt by integral dt. You can use to find average acceleration. You can do this. Next, if v is a function of x is given, velocity position equation is given, v is a function of x is given, to find acceleration, use a is equal to v dv divided by the dx. Similarly, in the above relation only, if a is a function of x is given, a is a function of x, to find velocity, you can use this relation v dv is equal to a dx. Integrate both the sides, you will get the velocity at any position x. This is what actually I am going to tell now. Now in this first lecture, I am going to write that how to use this relation among the all the physical whatever the kinematic terms are there. Apart from this, in any problem, if it is in retardation, in case of retardation, use a is equal to minus dv divided by the dt, or a is equal to minus v into dv divided by the dx. You don't forget this one. Okay, keep in your mind. Minus term you have to write. Now I am moving to the do some problems related to whatever I have given. See, I have taken some questions. I will do like very fastly. You can do all the problems. In 1 second, a particle goes from the A to B, moving in a semicircular radius of 1 meter. The magnitude of average velocity is what? Now particle is moving from the A to B, so we can see the displacement. This is the initial position, B is the final position. The displacement, we can see that displacement is 2 meters. Okay, we can see time is given, that time is equal to how much? 1 second. If you divide this, we'll get the V average value. That value you can get the 2 meter per second. We can tick the option B. Okay, next one. We can see a butterfly is flying with a velocity 4 root 2 meter per second in northeast direction. Wind is slowly blowing at a 1 meter per second from north to south. The resultant displacement of the butterfly in 3 seconds is how much? You can observe in this question, I am writing, this is east direction, north direction, west direction, south direction. You can observe that a butterfly is moving in north and east direction. So north and east direction with 4 root 2. It is exactly what angle they have not given. We can treat this is 45 degrees. If you take 45 degrees, we will get the 4 root 2 value is there. No, this 4 root 2, you can get the value of this 4 root 2 along x-axis can be written as 4 root 2 into cos 45 degrees. We will get the 4 root 2 into 1 by root 2. We will get the 4. Similarly, if you write along the north direction also, we will get the 4. Okay, 4 meter per second you got. And we can observe that one more body is there. Sorry, here it is given wind is slowly blowing at 1 meter per second north to south. So now which direction wind is moving here? You can see wind is blowing from the north to south. I have written like this in blue color. So this is the velocity of the wind. It is moving with 1 meter per second. 1 meter per second. Now we can see what is the net velocity of this butterfly along the direction, given direction. You can see that this butterfly, it will move like this. Butterfly will move like this. You can see this is the east direction. Okay, and we can see this is the north direction. Upward resultant velocity you can write it as 3 meter. Why? Because 4 minus 1. If you write 4 minus 1, you will get the 3 meter per second upward. Right side we can see that it is moving with 4. Now if you observe that the resultant velocity is this direction will be there. By using Pythagoras theorem, you can get the value is 5. If it is 5 meter per second is there, how much time it is taking? According to that, 3 seconds they are asking. In 3 seconds, how much distance it can move? Tell me now. In 3 seconds, it can move in a 5 into 3. That is 15 meters it can travel. So you can take the 15 meters is the answer. Okay, butterfly is moving. Overall velocity is 5. So 5 into 3, 15. Next one, a car covers a distance with first 1/3 at velocity v 1 meter per second, second 1/3 at v2 meter per second, and the last 1/3 with v at v3 meter per second. All the values are given. We can see that whenever a car is moving in different distances with different speeds. Now first 1/3 I am taking, this is s distance it is traveling with a speed of v1, and second s distance it is moving with a speed of 2v1, and last 1/3 it is moving with 3v1. Now total what is average velocity they are asking, as it is straight line and body is not turning back, so we can say that total distance and total displacement is same values will be there. I am rating that value only, average velocity. Average velocity can be written as total distance is s plus s plus s whole divided by the time taken, how much time it traveled with v1 speed. Distance s distance is t1 is equal to s divided by the v1. Similarly, the time in second is s divided by the 2v1. In the last 1/3 distance is t3 is equal to s divided by the 3v1. Now you substitute that all the time intervals. If you write that s by v1 plus s by 2 v1 plus s divided by the 3v1. If you take the s by v1 is taken common, 1 plus 1 by 2 plus 1 by 3. You can get the value as s divided by the v1 into LCM is 6 and you can write it as a 6 plus 3 plus 2. Finally, I will get the total time taken value is s divided by the v1 into 11 divided by the 6. As per the question, s you don't know, v1 value is 11 is given, 11 divided by the 6 if you write that, finally you will get the s divided by the 6 is time taken. You substitute the s divided by the 6 here. We can write 3s divided by the s divided by the 6. Now s and s get cancelled. Finally, we will get the 3 into 6 is equal to 18. So they are moving with meter per second. So we can write it as car is moving with meter per second. We can write the 18 meter per second. I am not using any formula, just a basic formula, whatever I have written, no, average velocity or average speed is, no, that distances only, just we can write the total distance by total time taken or total displacement by total time taken is, no, that we can write. So here, as per the question, 18 meter per second. Okay. Next question, a boy reaches the airport and finds that the escalator is not working. He walks up the stationary escalator in time t1. You observe this, stationary escalator, he walks. Okay. Let us consider the first situation. This is the escalator. Let us consider this is the escalator. Now a boy is walking from here to this escalator distance is, he is going to reach here. Now man is walking, whatever distance covered, let us consider he covers a distance of this. Okay, I am writing velocity of the man is equal to distance covered divided by the time taken t1 in first case. Now this is a case 1. Next case, what they are telling, if he remains stationary on a moving escalator, then escalator takes him at in time t2. Now you can see the initial position and the final position of this person where he wants to reach now, that he is standing here and escalator is moving. So with what speed it is moving? V speed it is moving. Now initial and final positions are same. Now in case 2, if you apply the same logic, we can write velocity of escalator is equal to distance length of that escalator, or distance can be written as VE is equal to S by T2. In third case, we can see that the time taken by him to walk up on the moving escalator. Now if escalator in case 3, escalator is moving as well as a person also moving, both at a time it is showing a velocity of the man is there, velocity of escalator also there. Now he can reach this distance is same only. He has to walk that same distance to reach the same destination. In this case, we can write it as velocity of the man plus velocity of escalator is equal to distance divided by the time taken t. Now you substitute the s by t1 plus s divided by the t2 is equal to s divided by the t. So finally we will get the 1 by t1 plus 1 by t2 is equal to 1 by t. If you do this, we will get the t is equal to t1 t2 divided by the t1 plus t2. This is the time taken by the man to reach on his destination on moving escalator, that is t1 t2 by t1 plus t2. Okay. Next one, a particle is moving eastward with velocity of 5 meter per second. In 10 seconds, the velocity changes to the 5 meter per second northwards. The average acceleration in this time is how much? You can see, as earlier I have given, particle is moving initially with what velocity it is moving in east direction. This is a north direction, west direction and south direction. First initially 5 meter per second, it is initial velocity. Okay. In 10 seconds, the velocity changes to the 5 meter per second northward direction. I am taking north direction, final velocity is a 5 meter per second north direction. Now we want what is average acceleration. You observe this A average value is equal to final velocity vector minus initial velocity vector divided by the delta t. If you observe this initial velocity vector is east direction, negative velocity of initial is what here? West direction will be there. This is a velocity vector. Now you can see that which direction he has to move. He has to go like this. This is the whatever the change in velocity is, that change in velocity direction. Now final velocity is, we can write it as 5 j cap minus 5 I cap. 5 I cap whole divided by the delta t value is equal to much. You can see that in 10 seconds. So you can write the magnitude of A average value is equal to 5 root 2 divided by the 10. You can get the 1 by root 2 meter per second square. But which angle, which direction is moving? We can see he is moving north and west direction. We can write it as northwest direction. Okay, you have to draw this diagram and identify change in velocity. Change in velocity is which direction is there? North and west direction is there. Okay, now you can see other question. In an engine of a train moving with a uniform acceleration passes the signal post with u velocity u and the last compartment with velocity v. The velocity with which the middle point of the train passes the signal post. Let us consider there is a signal is located here. Let us consider this is a signal. This is a signal. Assume that this is a signal. I will write properly. Let us consider this is a signal. Okay, this signal is there like this. This is a signal. Red signal is there. Now, initially, whatever the train is there, let us consider this is a train. This is a train. This is the engine of the train. Engine of the train. It is moving with a velocity u. Okay. Now, after some time, you can see that last bogie is there now. That this engine. This is the engine. Last bogie is moving with velocity v. Now, if you want to if you want to see the velocity of, if you want to calculate velocity of midpoint, you can see this is a midpoint which is moving with velocity v dash you consider. Okay, now you can see how much distance it is covering. This is a midpoint. Let us consider total distance is equal to how much here? 2x is there. So we can write initial case v dash square minus u square is equal to 2ax. Second case we can write v square minus v dash square is equal to 2ax. Okay, first distance x, second distance x I am writing. So if you add both the things, what value will get if you add both the things? A and x is not required now. You subtract this. If you subtract this, you can get the minus 2ax, or you can do one more thing also, just from the above relation and this relation, first equation and second equation. From 1 and 2, you can write it as v dash square minus u square is equal to v square minus v dash square. Now you can get the values 2v dash square is equal to v square plus u square. Now finally you will get v dash square is equal to v square plus u square divided by the 2, and v dash is equal to under root of v square plus u square divided by the 2. So you can see midpoint is under root of v square plus u square by 2. Okay. Next one, a scooter accelerates from the rest from time for time t1 at constant rate. Accelerate from rest means u is equal to 0. So I can write the velocity is equal to some acceleration a into t1. Okay. Next it is decelerating. So it decelerate from v to final velocity is final velocity 0. In this case, we can write it as V is equal to, we can write it as A2 into T2. Now, according to question, they are asking what is the relation between the T1 by T2. Just you write that from 1 and 2, you can write it as, from 1 and 2, you can write it as A1 T1 is equal to A2 into T2. So you can write it as T1 by T2 is equal to A2 divided by the A1. This is the relation for this. Okay, they have asked the simple questions only, few simple questions we can see. A small toy starts moving from the position of rest under the constant acceleration. It travels a distance of 10 meters in t seconds. Now 10 meters in t seconds they are asking. 10 meters and time is nothing but x is equal to, we are having from rest it is starting. So u value is equal to how much? 0. I am writing directly half into a t square. Okay, so first case we can write 10 is equal to half into a into t square. Second case, it travels distance traveled by the toy in the next t seconds. Means it is starting from here, u is equal to 0 at t is equal to 0. First it is traveled at 10 meters. Next t seconds means in 2t time how much distance? Distance travel in next t seconds they are asking. So you can write that is x2. So you can write x2 plus 10 is equal to half a into 2t whole square. We can write x2 plus 10 is equal to half into a into 4t square is there. From above data, you can see half a t square value is equal to 10. You substitute there. X2 plus 10 is equal to 40. X2 is equal to much? 30 meters. So he covers next t seconds. He covers with 30 meters. A particle is moving in a straight line in such a way that velocity increases at 5 meter per second per meter. Here they have given how the velocity is v is varying with distance. So I am writing dv by dx value is equal to 5. Okay, that's why 5 meter per second by meter. Okay, dv by dx is given. The acceleration of the particle at t is equal to at v is equal to 20 meter per second. I have given is a v is a function of x is given. To calculate acceleration, we are having v dv divided by the dx. I given earlier, we can apply that. So 20 into 5, that value is 100 meter per second square we can write. So our answer is how much here? 100. Next one, the position of a particle as a function of time t is given like this. X is a function of time is given. They are asking that here a, b, c are constants. The particle at a zero acceleration, what is the velocity? First you calculate velocity. As v is x is a function of time, v is equal to dx by dt. We can get the acceleration. This is a plus 2bt minus 3c t square. This is the velocity. Now acceleration, as they have given already small a is given, that's why capital A is the acceleration I am taking. dv by dt. What is the dv by dt value? 0 plus 2b minus 6ct. So this value according to question, acceleration is 0 is given. I can substitute there. Finally 2b is equal to 6 ct. T is equal to b divided by the 3c. Now you can substitute this value here. If you substitute that, finally you will get some v value. Now v is equal to a plus 2 into b divided by the 3c minus 3c into t square value is b square divided by the 9c. So v is equal to a plus 2b square minus 3c, and this 3c and 9c, 3c times get cancelled. 2b square by 3c minus b square divided by the 3c is you can get the a plus b square divided by the 3c. This is the required answer. Observe this carefully. Next question, a particle is moving with a speed v is equal to b root x along positive x-axis. Calculate the speed of the particle at a time t is equal to tau. They are asking what is a tau. You observe this carefully. V is a function of x is given, but they are not asking acceleration. What they are asking? Speed only at a time they are asking. You don't want x relation. Okay, we don't need x in equation. That's why what you have to do, need time t. When we need time t, first you convert this into time. Dx by dt is equal to b into root x. So you can write dx by root x is equal to b into dt. Now integrate at 0, 0 position is there. At any time t, position is x. We can write 1 by integral of 1 by root x into dx is equal to 2 root x. I hope everyone knows this one. I am writing 2 root x, limits if you apply 0 to x, and b into t, integral dt value is equal to t. So I am writing 0 to t. Finally, you will get the 2 root x is equal to b into t. Now x is equal to b t square divided by the 2. As per the question, they are asking at t is equal to 0, and at a time t they are asking. At time tau, t is equal to tau they are asking. X is equal to b tau square divided by the 2. This is our required answer. Okay. Now, next question. The distance x covered by the particle in one dimension motion varies with time t as x square is equal to a t square plus 2bt plus c is given. You observe in this question, x is the function of time is given already. Acceleration of the particle depends on x. Again, we need a is a function of x relation you want. Acceleration means I am writing capital A. We need capital A relation. First, you get the velocity. Okay, what is the A value? A is nothing but dv by dt that you need in terms of x. How to write? Differentiate this. Differentiate with respect to t, time t. We can write 2x into dx by dt is equal to 2at plus 2b. Now 2 get cancelled. So finally we can get the x into dx by dt is v, at plus b. I am getting v is equal to at plus b divided by the x. But I don't want a t term. Okay, now I want like acceleration a is equal to dv by dt is a differentiate this. I am writing like a at plus b differentiation of x, that value is 1 by x minus 1 by x square into dx by dt plus again I am writing like a at plus b. I have to differentiate now. 1 by x I am keeping there only, a plus 0. Now you can get the acceleration a is equal to minus at plus b. You observe this carefully. Dx by dt, this value is how much? Dx by dt, nothing but you can substitute that value. We can write at plus b by x square is there, x cube we can write, plus this value a divided by the x. Finally, I can get the minus at plus b whole square plus a into x square whole divided by the x cube. Okay, you don't want to time also. How to eliminate the time taken, you see here now. Only x value you want now. You can write at plus b whole square value is equal to a square t square plus b square plus 2abt. We have like a this relation. You just observe that given relation x square is equal to at square plus 2bt plus c is there. Okay, from there you can eliminate the t term. How to eliminate t term? You just multiply with ax square is equal to a square t square plus 2abt plus ac. Now ax square now minus ac is equal to a square t square plus 2abt. Now is same thing, you can substitute in this equation, a square t square and this value is there now. Now you can get the what is a square t square plus 2abt value is this. You just substitute that value in place of this. So you can write it as, if we substitute here, I can get the finally at plus b whole square is equal to ax square minus ac plus b square is there. Now from this relation, I can get the acceleration is equal to negative of ax square minus ac plus b square whole thing plus ax square whole divided by the x cube. That is minus ax square plus ax square get cancel. ac minus b square divided by the x cube. Now you can see all are in terms of the constants only. These are constants. Okay, if it is constant, we can see acceleration is directly proportional to the x to the power of minus 3. If x to the power of minus 3 is there, you can get the answer is how much? 3. Okay, observe carefully. Next one, the velocity of a particle is v is equal to v naught plus gt plus ft square. Its position is x is equal to 0 at t is equal to 0. Then displacement after time t is equal to how much they are asking. V is equal to v naught plus gt plus ft square is there. Here v is a function of t is given. We need x is a function of t. We need to differentiate. I told no, integrate. I told no. Integral dx is equal to integral v dt. We can write. So 0 to x and 0 to 1. You observe this, x is equal to integral dx is equal to x only. V naught into integral dt 0 to 1 plus g into t dt integral 0 to 1 plus f into t square into dt integral 0 to 1. If you substitute there, you will get v naught into 1 plus g 1 square by 2, that is 1 by 2, plus f into t cube by 3, that value is 1 by 3. So required answer there is a option 3. Just reference purpose I am explaining these questions. You can pause this and you can solve this question, and you can check the your result with my result. The relation between time t and distance x for a moving body t is equal to mx square plus nx is given. M and n are constant. Retardation you need to calculate. Retardation is nothing but you need to get the minus dv by dt value. I am writing now. Differentiate with respect to time t. Why should I do with respect to t? You need to get the dx by dt value is equal to v. Again we can write the dv by dt value is equal to acceleration. That's why. Okay. Now differentiating. Differentiation of t is 1. We can write it as 2mx into dx by dt plus n into dx divided by the dt. I can get the 2mx into v plus n into v. From this v is equal to 1 by 2mx plus n. Again differentiate this. I need acceleration, that value is dv by dt minus 1 by 2mx plus n whole square into differentiation of 1 by x is there, no? The differentiation of 1 by x is equal to much minus 1 by x square into, that's all. Now I am doing with respect to t, no? That's why I am writing d by dt of 1 by x is equal to much minus 1 by x square into dx divided by the dt. Same thing here also I am writing dx divided by the dt. Again dx by dt is nothing but we have written that velocity v. Substitute there. A is equal to velocity v is nothing but we can see that 1 by that value is there, no? So we can write minus v square into v. So minus a is equal to v cube. They are asking how retardation is there. So we can write the one more thing I forgot, dx by dt into 2m also there, no? That 2m you write 2m. So finally you can get the value is minus a value is equal to 2m into v cube. This is a required relation. So 2m into v cube. Okay. Next question. The instantaneous velocity of a particle moving in a straight line is given by v is equal to alpha t plus b t square. Now you need to calculate distance covered. Again I am telling v is a f of t is given. We need to calculate the x is a function of time taken t. How do you do this one? Integral dx is equal to integral v into dt. They have given 0 to x and here 1 to 2 they have given. Just to substitute there. I hope everyone knows the integration 1 to 2 plus we can write it as beta into integral t square into dt 1 to 2. If you do the calculation you will get the answer is how much? 3 by 2 alpha 3 by 2 alpha plus 7 by 3 beta you will get. This is the distance x. Okay. Next question. If the velocity of a body related to the displacement x as v is equal to under root of 5000 plus 24x is given. you can write this v square is equal to 5000 plus 24 into x. We can compare with v square is equal to u square plus 2ax. Now you can see 2a value and 24. As it is same is there, we can write it as 24 is equal to 2 into a is equal to how much? 12 meter per second square. If you want to, you can do like a v dv by dx is equal to acceleration is there, no? That also you can do, same kind of relation you will get. Okay, so answer is equal to 12. Next, two buses P and Q start from a point at the same time and moving in a straight lane. Their positions are given like a first xp is given alpha t plus beta t square, and xq it is given that ft minus t square. We can see x is a function of time taken t. We need velocity. At what time they are having same velocity. V is a function of time you want. How to calculate velocity is a function of time. You have to differentiate. So dxp by dt is equal to alpha plus 2 beta t. Similarly, dxq divided by the dt, if you write that, f minus 2t you will get. As per the question, this is the velocity of the p, this is the velocity of q. Both are equal. At what time it is equal, they are telling alpha plus 2 beta into t is equal to f minus 2, earlier they have given t square and 2t. So you can get the f minus alpha is equal to 2t taken common. You can get the value is 1 plus beta is there. So you can get the t is equal to f minus alpha divided by the 2 into 1 plus beta. Required answer is there 4. Next question. This is the 2017 JEE advanced question. Consider an expanding sphere of instantaneous radius r. Let us consider there is a r. Okay. Now this r is at any time. Let us consider r is r. Now it is going to expand. It is expanding. At any instant it is r. Okay. This is at a time t. It is expanding. Now we can see that rho is uniform, m is constant, mass is constant. We have mass is equal to volume into density. Volume is nothing but 4/3 pi into r cube into density rho. Now you no need of this mass is constant here. That's why dm by dt I am doing now. 4/3 pi r cube value is equal to, you can write as 3 into r square into dr by dt into rho plus you can write it as r cube into d rho divided by the dt. The whole thing is 0 as mass is constant. So you can write it as 3r square into dr divided by the dt into rho is equal to minus r cube into d rho divided by the dt. Now you can see this r square is one time get cancelled. Finally we can get the dr divided by the dt is equal to minus 1 by rho into d rho divided by the dt into 3 divided by the rs. Sorry. You can get the value is equal to much r cube value we are writing now, r by d rho by dt, r divided by the 3 is there. Okay, correct only. Now you can see dr by dt is velocity. Okay, that is dr by dt is equal to minus 1 by rho into d rho by dt. This is constant. Now you can see value is r by 3. Now you can see whatever velocity is there, that is directly proportional to r. They are asking what is the proportionality. How it is depending on r. It is proportional to r. Okay. Now next question. A solid horizontal surface is covered with a thin layer of oil. A rectangular block of mass 0.4 kg is at rest on this surface. Let us consider there is a surface and this block is at rest. Mass is given. It is given some impulse of 1 Newton second is given. We can say that this impulse J. Impulse J is equal to mass into initial velocity. J is 1, mass is 0.4, initial velocity is they have given v naught. You also take like a v naught. So v naught and here also v naught. V naught is equal to 10 divided by the 4. You can get the 5 divided by the 2 meter per second. Now they are asking now applied so that it starts moving along the x-axis with v is a function of time taken is given e to the power of minus t divided by the tau value they have given 4. Okay, 1 minute. They have given tau. T also they have given tau only. Okay, we will see now what is the displacement. Integral dx is equal to integral v into dt. Integral v naught into e to the power of minus t by tau into dt. What is integral dx value? X. And integral v naught is actually constant. You bring that e to the power of minus t by tau, limits are 0 to tau, here 0 to x is there. Okay, divided by the minus 1 by tau is there, limits are 0 to tau. Substitute there, x is equal to minus 5 tau divided by the 2 e to the power of minus 1 minus e power 0 is 1. We can substitute that minus 5 divided by the 2 into tau is equal to 4 e to the power of minus 1 minus 1 is there. So you can get the 5 and this is actually you can see 2 times get cancelled. 10 into 1 minus e to the power of minus 1. 10 into 1 minus e to the power of minus 1 is this is actually e power minus 1 is 0.37. 10 into you can write it as 0.63 you can write. This value approximately 6.30. Now you see answer they have given 6.30. So I am telling integral dx is equal to integral v dt, that is only concept. See in 2023 JEE Advanced 2023 they have given a question like this: a person of height 1.6 meter walking away from the lamp post of height 4 meters. Height of the post you can see I have already written 4 meters. Straight path, a flat ground. The lamp post and a person are always perpendicular, so that man I am taking actually along x-axis and lamp post is and y-axis is there. If the speed of the person is 60 centimeter per second, speed of the tip of the person's shadow on the ground with respect to person is equal to how much? Is a person, whenever light is falling, we can see what is the tip of this. Okay, tip is I have taken like a vs speed I have taken. As per the question, vs is equal to dy by dt. Okay, dy by dt means from lamp post distance of the shadow is vs is there, that is located at a y distance. Okay, now we can see that from the similar triangles, 4 divided by the opposite side divided by the total distance is equal to y is equal to 1.6 is there. Height of this person is 1.6 divided by the this distance I have taken y minus x from shadow to the person, tip of the shadow to the person. I differentiated this. I got the values dy by dt is equal to 100 centimeter per second. But they are asking velocity of the tip of the shadow with respect to person they are asking. So this dy by dt is with respect to post, lamp post. Okay, now you want with respect to person. Now we can write velocity of the shadow minus velocity of the shadow with respect to person they are asking. Velocity of shadow minus velocity of the person. Velocity of the shadow with respect to post is 100. Velocity of the person is 60. We will get the 40 centimeter per second. As per this, 40 is the answer. I hope you understand this and you enjoyed this. Next session, next lecture, I will explain the motion under gravity and remaining things like graphs and motion